Ever since Apple launched its M1 chip back in 2020, I've been wondering how long it would take for similarly powerful ARM chips to come to PCs. Just 3 months after those first M1 machines hit the market, Qualcomm acquired a chip design firm called Nuvia, which was a company that was founded by former Apple Silicon engineers who'd worked on the A-series iPhone and iPad chips. And I was really excited by this news, thinking that the M1 moment for PCs would follow soon after. And as it happens, it took another 3.5 years for the first chip to hit the market, during which time Apple has rapidly progressed the performance and efficiency of its chips, making a hard act to follow. Intel and AMD have also pushed forward with their chip designs too, offering great performance and in some cases pretty decent efficiency. So it's a much more competitive landscape that Qualcomm finds itself in now. But even so, this should have been a key moment for the PC market and a really important launch. But I think it's fair to say that Microsoft has bungled it somewhat, much like it's bungled each previous attempt to make Windows for ARM happen. And I'd like to share my thoughts on that, but I'd also like to share my experience on what it's actually like to use these laptops. I've been using these Snapdragon X Elite machines for a few weeks now, and one of them has actually become my daily driver, so spoiler alert, I quite like them. And I think there is something interesting on offer here, despite the launch debacle. But as with any first-generation product, they're not going to be suitable for everyone, and we need to expect some teething issues. When Apple introduced the M1, it was after years of silicon design and refinement. The CPU and GPU core designs had already been used in the A-series chips, tried and tested in the wild on an operating system that has the same underpinnings as macOS. And Apple really put some effort into the transition. They provided developers with the Developer Transition Kit, a Mac Mini with an A12 chip in it running macOS. And devs got it for a discounted price, and they got that money back in credit towards a new machine when they returned the dev kit after 1 year. Apple also provides a huge amount of developer resources, support and training. And that's why it didn't take all that long for the transition to become successful, to the point where creative professionals started buying Apple Silicon Macs for mission-critical workflows. How does the Windows for ARM experience compare? Now let's be fair here, Apple has a huge advantage because it controls the silicon, the hardware it goes in, and the software which runs on it. Whereas here we've got Qualcomm producing the silicon, various hardware manufacturers implementing it, and then Microsoft providing the software that runs on it. And it's just impossible that these separate companies, even when collaborating, could ever match the tight integration that Apple has, especially when Microsoft is in the mix. Microsoft doesn't seem to understand at all what its users want, and instead it persists in forcing users to do things they don't want. Their focus is entirely on shareholder return, and if they force users to use things like Bing by default, that inflates their usage numbers and keeps the shareholders happy. When it actually comes to making a meaningful transition to ARM, Microsoft keeps failing. This is hardly new. Microsoft has been working on Windows for ARM for years, but up to now, each device they've brought to market has been a bit meh, failing to deliver on promises and disappointing consumers. But this time, Microsoft has actually been doing a bit of legwork. Developers could buy an ARM dev kit last year with the Snapdragon 8cx Gen 3 chip in it. But that's not a huge amount of use for this new chip, because whilst the chips in these laptops bear the Snapdragon name, it's not a generational progression on previous Snapdragon chips. This is an entirely new design, a 12-core CPU coupled with an Adreno GPU, and some other optimizations like video encoders and decoders, and also a powerful neural processing unit, or NPU, for on-device machine learning and AI tasks. Qualcomm has promised a developer kit with the X Elite chip in it. It was supposed to launch on June 18th, and to my knowledge, it still hasn't launched. I'm on the waiting list for one and I've heard nothing yet. And I think this is a huge problem. Developers wanting to port to ARM using the X Elite are forced to go out and buy one of these laptops. And they'll probably need the most expensive models with 32 gigs of RAM in order to compile their apps. But Apple made their developer kit available before the product launch. Now, how was this Windows launch managed so badly or so rushed that developers have had to wait until after the products hit retail shelves in order to get a dev kit? It just makes no sense. Small wonder then that these laptops have a high rate of return and have already been steeply discounted. Is it really a surprise though when Microsoft chose to conflate the launch of these new ARM chips with all their AI vaporware? Customers are being promised a new era of AI computing which doesn't really exist yet. The flagship feature of the Copilot Plus PC was to be Recall, a system that snapshots what you're doing every few seconds so that on-device machine learning can build a history of everything you've done. And that's great. If you need to ask the on-device AI, what was that website I looked at about 3 weeks ago, or where did I save that particular file? But do you want your computer spying on you like this? And the system was so badly designed, it was basically storing data in plain text in a database on your machine. Unsurprisingly, then it got ripped to shreds immediately by anyone who knows anything about IT security. And as a result, Microsoft had to pull its flagship feature from the launch. And it's still not available. So customers are going out, buying a Copilot Plus PC, expecting some AI revolution. And what they actually get is the Copilot chatbot that they already had, attached to a special key on the keyboard. Big whoop. So in its rush to jump on the AI hype train, Microsoft missed the opportunity to really focus on getting the ARM experience right, supporting developers, and making the most of the possibilities that ARM brings. Despite all of this, though, developers are working hard to provide support, and there are major apps that have been made available since the launch. But this leads us to another problem with the launch, and that is that some of the tech press coverage you may have seen, there's this line of reasoning, particularly in the YouTube tech sphere, that you've got to get your content up first in order to get the views and make the ad revenue. And, well, perhaps that is true, but if it is, it only benefits the creator. It's pretty poor for you, the viewer, because it takes a day or two just to write a script, film, and edit a basic review. So you've got to ask how much real testing and usage gets done with reviews that are published just after launch day. This is particularly an issue with a first-generation product like this. There are bound to be bugs and kinks that need to be worked out. And some of the things that early reviewers mentioned have already been addressed. I've actually only had one weird issue with apps refusing to open, and it was due to a piece of software that I installed, and it had installed the wrong version of the Visual C redistributable libraries. I looked at the error message, realised what had probably happened, and I downloaded the correct ARM version from Microsoft's website. That fixed it. True, an everyday user wouldn't know to do that, but by the time I installed the same piece of software on this ASUS laptop just a few days later, the bug had already been resolved. So you may be left feeling, what's the point in these X Elite machines? Well, they may not be as game-changing as Apple's M1 was, but realistically that was never going to be the case. And it's a completely unfair expectation. Despite this, though, the performance on offer is actually really good. The CPU cores in the X Elite are all performance cores. And that's a departure from the normal ARM designs, which usually feature a combination of performance and efficiency cores. But it does seem to work, because these laptops are not struggling with power efficiency. In fact, they outperform the MacBook Air when it comes to battery life. You get all-day battery and then some, provided you're not working them too hard. And there are actually a few different models of the X Elite, with some variants offering a higher boost performance in lighter loads, and a more performant GPU. There's also a binned version of the chip with 10 cores, and that's called the X Plus, which is available in slightly cheaper laptop models. That said, we've already seen from industry tests that buying a laptop with a more powerful X Elite version doesn't necessarily mean you'll get more performance. Thermal designs and the way the laptop manufacturer implements the chip will make a difference. And that's the case with these two machines here. So we've got the Lenovo Yoga Slim 7X and the ASUS Vivobook S, both featuring the entry model 78100 X Elite chip. Both laptops have 16 gigabytes of RAM, which is not upgradable, and they have a 1TB Generation 4 SSD, which is. For comparison purposes, I've also got a MacBook Air with the M3 chip. Now this has got 16 gigs of non-upgradable RAM and a 512GB SSD, which is also not upgradable. Thanks, Apple. Since these X Elite laptops are targeting broadly the same market as the MacBook Air, it makes sense to compare them. So let's jump straight in with some benchmarks, starting of course with the obligatory Geekbench 6 CPU test. Looking at the single core performance numbers, we can see the Lenovo and ASUS are broadly similar, coming in at 2465 and 2429 respectively. We could call this basically the same within a margin of error. Both laptops were plugged in and set to best performance in Windows, and I'll talk a little bit more about this in a moment. Let's add the M3 MacBook Air, which scores 3051. But of course, the M3 isn't actually the most current M chip, as we've now got the iPad Pro models with an M4 chip. And we can run Geekbench on the iPad, and the scores are directly comparable. So let's do that. So the 9-core version of the M4 with 8 gigs of RAM scores 3640, and the 10-core version with 16 gigs of RAM scores 3766. So unsurprisingly, Apple is holding the crown for single-core performance with its latest generation chips. But since I've also tested an M1 MacBook Air with 16 gigs of RAM, let's pop that on the chart as well. It scores 2388. So we can see that the X Elite is coming in just ahead of M1 for single core. And I think that's actually really impressive for a first outing. But multi-core is where it gets really interesting. Here the Lenovo scores 13,822, but the ASUS Vivobook S pushes this out to 14,278. That's faster than the M3 MacBook Air and the 9-core M4, and it's very close to the 10-core M4. That is a very nice amount of performance. And now we're starting to see the effects of thermal differences. The Vivobook here is a larger chassis, so it's able to cool the X Elite chip more efficiently than this Lenovo can, and hence the higher score. But the ASUS also has a full speed mode, which allows the fan to run at maximum speed. So what happens if we redo the test with that option selected? The ASUS jumps up to 14,451. Interesting. Let's just talk about the different power modes now. Windows offers a choice between best power efficiency, best performance, or a balanced approach between the two. And you then have differences that depend on whether you are plugged into a charger or not. So if we keep the laptops plugged into chargers, but we'll select the best power efficiency mode, then we start to see a slight reduction in performance for single core on both of these machines. When it comes to multi-core, the Lenovo is basically the same as before, and the ASUS has a very marginal drop. But really, there's very little difference between the two modes if you're connected to a charger. So what if we disconnect the charger and run on battery? Let's first of all choose the best performance mode. And yes, we can see a more noticeable drop here in peak performance on the Lenovo, but it's hardly night and day, and I'm not sure you'd even notice the difference in the real world. You certainly wouldn't notice the difference on the ASUS because it's basically giving you the same performance. Finally, let's choose best power efficiency whilst running on battery and redo the test. And now we can really see a substantial difference versus peak performance, but let's be realistic here, these are still great scores, and clearly there is more than enough computing power available for the vast majority of what these laptops will be used for, so why not make use of the power efficiency mode and stretch out that battery life even more? Of course, the Geekbench CPU test is a series of fairly light loads rather than a continuous sustained load. So let's jump over to Cinebench 2024 and run a 10-minute CPU rendering test. And starting with single core, the Lenovo scores 107, the ASUS 106, and the MacBook Air takes the win with 141. No real surprises there. The multi-core test is more interesting. Here, the Lenovo manages 890 and the ASUS 906. But the M3 MacBook Air is some way behind at 590, and that's a much wider gap than the Geekbench 6 numbers would suggest should be the case. But there is a simple reason for that. The MacBook Air has no active cooling, whereas both of these X Elite laptops have fans to cool their chips, and this helps to deliver sustained performance. The M3 chip itself is more capable than these numbers suggest, but the thermal throttling with the MacBook Air is a real issue. I demonstrated this recently in a video showing how the M3 MacBook Air actually lost to an M1 iMac in a video rendering test. In fact, it was also beaten by a 2013 Mac Pro in that test. Quite enlightening. Now, does the presence of fans mean that these laptops are loud? No. Most of the time they're not spinning, and even when they do, they are pretty quiet, until you turn on that full speed mode on the ASUS. If we do, it does manage to boost the Cinebench score all the way up to 1077. That's a pretty impressive 19% improvement, but there's a price to pay. When spinning at full speed, the fan noise is pretty obnoxious. But that said, I expect there'll be plenty of users who would be happy to have this option for their occasional heavy workloads. Now, comparing Macs with Windows PCs generally results in comments from fanboys on both sides, but that's not the goal here to start arguments. What you've got to remember is that hardware is only part of the overall machine. Software is just as important. And if you prefer Mac, I doubt you'll be interested in switching to one of these X Elite laptops, regardless of the benchmarks. And likewise, if you prefer to use Windows, you're probably not going to choose a Mac. But fans on both sides of the argument should be happy that these machines exist. For PC users, it's great news because it means you get to enjoy the same long battery life and crazy mobile performance that Mac users have been enjoying. And Mac fans should be happy for competition. Competition will drive Apple to make better chips and hopefully better design and spec choices. Now, that's provided Microsoft stops shooting itself in the foot, of course. Now, when it comes to pricing, these X Elite laptops are cheaper than a MacBook Air when spec'd with the same memory and storage by a whopping £400 here in the UK, and that's before you factor in the discounts that are available. And the spec you're getting is pretty great. We've got OLED displays for starters, a 90Hz touch panel here on the Lenovo, and a 120Hz non-touch panel on the ASUS, and both look amazing, especially when you throw some HDR content at them. When it comes to build quality, I'd say in the case of the Lenovo here, it's every bit as nice as the MacBook Air. And overall, what this means is these laptops represent great value for PC fans. And you Apple fans should welcome them too, because maybe it will prompt Apple to improve its value proposition, perhaps increasing those base specs and reducing the entry price. I've done a lot of tests with these laptops, and I'll be featuring more of those in a dedicated review of each machine. The Vivobook S is on loan from ASUS and I need to send it back, so that one will come first. But the Lenovo Yoga Slim we bought for testing, and I've been daily driving it for a few weeks now, in place of the M3 MacBook Air. Now, this isn't a Mac guy tries Windows situation. I actually use macOS and Windows equally. My main workstation for video editing is a Lenovo ThinkStation, but you'll also find me on a MacBook Pro just as often. I think that this lack of personal preference is important for giving an unbiased opinion to you, the viewer. Now, in spite of Microsoft's dropping of the ball, I do still feel that it's important to keep in mind that these are first generation products, so there will be teething troubles. Fair enough, overall there were fewer issues with the M1 machines when they launched, but there were still issues, and some were pretty critical, like that bug in the Rosetta translation layer that caused vast amounts of data to be written to your non-replaceable SSD. And then there's the lackluster USB performance on the M chips that still hasn't been fixed. And as I recall, creative professionals didn't immediately jump from their Intel Macs to Apple Silicon for their mission-critical workflows. It makes sense to wait a while for these things to mature if you've got more niche requirements that are critical to your business. And the same is true for these X Elite machines. Yet for some reason I'm seeing tech reviewers complain because some very specific piece of software for a pro workflow is not yet compatible. In fact, you might assume from all of this that using these X Elite chips will be a frustrating nightmare of incompatibilities. But that just hasn't been my experience. I see these as general purpose computers, and they already work well for users who just want a fast portable machine with long battery life. You can install Office apps, connect your Wi-Fi, browse the web, watch video content, listen to music, pair Bluetooth devices, install printers, use USB hard drives and network storage. It all just works. And for apps that don't yet have ARM versions, there is the Prism translation layer. You can literally run non-compatible apps through emulation, and it is in many cases seamless. But that's not to say that it works with every single application. It doesn't. So you need to go in with your eyes open and do your research on the apps that you like to use. And frustratingly, there are also cases where the developer of an application prevents an app from installing for no good reason. An example of this is Apple Music, where Apple has, probably very deliberately, not yet made an ARM version of the software for Windows, so you can't download it on the Microsoft Store. But you can download the old and out-of-date iTunes, which doesn't have an ARM version, and that runs fine through Prism Translation. And in fact, users have already worked around this problem and proved that Apple Music actually runs fine through Prism. So yeah, there's some nonsense to deal with at the moment, but this will get fixed in time. What about creative apps? Many developers are working on ARM versions, or they already have public beta versions available. DaVinci Resolve 19 will support Windows for ARM, and you can download a fairly mature beta of that right now. Adobe has beta versions of some of its apps, and other things are already available, like Photoshop and Lightroom. After Effects and Premiere Pro are definitely in development. I use Affinity Photo rather than Photoshop, as do many these days, and Affinity's suite of software is already available for ARM and it runs very well on these laptops. So seems like a good time to look at the Affinity Photo 2 benchmark results. We can see that the X Elite compares favourably again with the M3. It's a little behind on single-core tasks, but it runs ahead on multi-core CPU tasks. Where it loses out is when it comes to GPU performance, so let's just talk about this for a moment. Here are the Geekbench 6 GPU results for OpenCL. We can see a fairly wide performance gap from X Elite to M3. If we switch over to the Vulkan framework for the PCs and Metal for the Mac, you can see that that gap gets even bigger. The Adreno GPU is the weak point of the X Elite chip. Now, part of that might be down to software not yet being fully optimized for it. By comparison, Apple's Metal framework is mature and it's really well supported by apps like Resolve and Affinity Photo, even to the point where it scores much higher than you might expect when compared to GPUs from the likes of Nvidia. More optimization and better drivers will come for X Elite, but it's still not going to be on par with Apple's latest chips or AMD's onboard GPUs. We'll need to wait for future generations to see how Qualcomm and software developers build on this. This doesn't mean that the GPU provides a really poor experience though. I personally haven't noticed any major real-world issues when using Affinity Photo for my workflow. And in day-to-day use, the X Elite machines just feel snappy and responsive. I've had the Lenovo connected to my 4K monitor, that works just fine. Now sure, they're not gaming machines, but that doesn't mean that they can't run some games. But of course, if you want to game on a laptop, your best option is still a PC gaming laptop with a dedicated GPU. That may change, but it's probably a few years away yet. Let's now also just talk about USB and Thunderbolt performance. These laptops both have USB 4, and since these are the most confusing standards in the world, we should take a moment to explain what that means, because there's plenty of misinformation out there. I'll try and just keep this really simple. USB 4 is like a combination of previous USB standards and the now open Thunderbolt 3 standards. And that's how USB 4 can achieve its advertised speed of 40 gigabits per second. USB 4 can also have official compatibility with Thunderbolt 3, but to have that official support requires something called PCIe tunneling. And this is optional for a USB 4 host like a laptop. If the manufacturer wants to claim official Thunderbolt support, then they do need to support this feature. And that seems to be the case here with these two machines. And I suspect it's true of all of the current X Elite models, but you might want to do your own research because I haven't personally tested them all. So it does mean that with these laptops at least, you can use Thunderbolt storage drives and docks. I've tested the USB performance with the Samsung T7 drive, and you can see that both of the X Elite machines delivered read and write performance at the levels you would expect. And they are more performant than the MacBook Air. Those standard M chips are still struggling with USB, it would seem. But let's try a Thunderbolt 3 NVMe drive enclosure. And here we see fairly mediocre performance on X Elite. In truth, it's not the best SSD in that enclosure, but as you can see from the MacBook Air results, it is capable of more. I would expect a true USB 4 enclosure to be more comparable on speeds between the two different platforms, and I do have one of those to test and review soon, so I'll check that out. So perhaps a good time to remind you to subscribe and hit the bell if you want to be notified when that content lands. Thank you for your support. I am very grateful. Now, speaking about Thunderbolt, I was also curious to see what would happen if I connected an eGPU. So I hooked up my Razer Core X to the Lenovo here, and it was detected just fine. The USB and Ethernet ports on the eGPU work, and the AMD 5700 XT GPU showed up as a basic display adapter in Device Manager. But there aren't currently any Windows ARM drivers for AMD and NVIDIA GPUs, so that's as far as you can go for now. But if those companies do produce drivers, I see no reason why these X Elite machines couldn't be paired with an eGPU for gaming, and I'll certainly be doing some more testing on that. So maybe it hasn't been the M1 moment for Windows that I was hoping for, but it's not a total disaster either. This hardware is really good, and the developer support is continually improving. It's going to take longer than Apple's transition, but realistically, that was always going to be the case. And I just hope it doesn't run out of steam before it really gets going. We as consumers need competition in the marketplace, and we need the efficiencies that ARM can bring. Microsoft and the manufacturers need to stop with all of the silly promises and claims and just knuckle down on improving the experience for Windows customers. And actually that's true of x86 machines too. Now if you're more of a Linux persuasion, you'll need to wait a bit. Qualcomm is still developing the driver support for these chips, but when it comes, that will open these laptops up to another audience. But my experience suggests that even now, many users could move to one of these laptops for their everyday computing. And I've really enjoyed testing and using these laptops. So stay with the channel for more X Elite content and dedicated reviews of these two laptops. I hope you found this useful and informative. Thanks as always for spending some of your time with me today, and I hope to see you again soon for some more geekery.